This is section 10.1 and it is on circles. The definition of a circle is that it's the set of all points the same distance from a given point in a plane. If we didn't have that little definition added, or that little part of the definition added on there at the end, then it wouldn't have to be in the plane, which would mean instead of a circle, we'd be talking about a sphere. Some of the different parts we have in a circle would be the radius. A radius is a segment that goes from the center of a circle to any point on the circle, and what makes the circle unique is that any radius that you draw would be the same. Diameter. Diameter is any segment that has endpoints on the circle and passes through the center of the circle. And in order to have congruent circles, the circles would be the same size. All circles have the same shape. All circles are similar. They're congruent if they have the same radius, the same diameter, or they have the same area. Now, some other segments that you probably haven't heard of before. First of all, the chord. A chord is a segment that has both endpoints on the circle. So there is a chord, and if you go with that definition, that means a diameter would be considered a chord as well. Secant. A secant is a segment, line, or ray that intersects a circle in 2 points. So this green line would be considered a secant. And then a tangent. A tangent is a line that is coplanar to a circle and intersects it in exactly 1 point. So as I come in through here, I hit it at 1 point and then keep going. So this red line is considered a tangent. Again, it must be coplanar. It's not like you have another line coming from a different plane and just hitting through it at 1 point. It's got to be coplanar with it, and it has to be from a line. I couldn't say that this little segment is a tangent because it only intersected in 1 point, because if I continued this segment into a line, it would intersect it in another point. So that's why the definition for tangent has to deal with the line. Intersection of circles. How can circles intersect? Well, it can have two circles that intersect in 0 points, or my intersection could look like this. I could have 2 circles intersect in 2 points, so it could look like this. It would also be possible for my circles to intersect in exactly 1 point. In this case, the 2 circles are considered to be internally tangent to each other. The other way I could get 2 circles to intersect in exactly 1 point is if they are externally tangent to each other. And that's just for 2 circles. Concentric circles. Concentric circles would be like the examples that we have here. Concentric circles are coplanar, and they also have the same center. Again, they have to be coplanar. If they're not coplanar, it doesn't meet our definition for concentric. Circumference. Circumference is the distance around a circle. The equation that we use for circumference is either 2 pi times the radius, but since 2 times the radius is the diameter, we could also say that we calculate it using pi times d. Another word for circumference would be perimeter. Next, when we look at polygons that are either inscribed or circumscribed, as I'm drawing this polygon, I am drawing it so that it's tangent to the circle at each point. And this would be an example of a circumscribed polygon. The circle is inscribed and the polygon is circumscribed. Whereas if I draw it so that the polygon is on the inside, then those words are going to be changed around. So now the polygon is inscribed and the circle is circumscribed about it. So know the difference between those different pieces of terminology. Tangents. I can draw tangents, a line that's tangent to both of these circles. For example, here is a line that's tangent to both of them, and this red one would also be tangent to both of them. I can draw a little bit better. Those are considered external tangents, whereas if I have a segment that cuts through the middle, is tangent here, is tangent there, then this green one would be considered an external tangent. Likewise, I can draw another tangent that intersects here, intersects down there, and those would be also considered to be internal tangents. The last thing we have in this section is what it means to be a radius. So if I have a circle and I have this tangent to that circle, I could draw in a radius to that point of tangency, and what I know is then that this radius and this tangent would be perpendicular to each other.